Okay, so here's one of the questions we had for homework. We had question 1, the first 5 parts. This is just part 3, so it's just a quick recap on what we did yesterday. The question says solve for theta, okay, where theta is between 0 degrees and 360 degrees. Then tells you the sine of theta is equal to minus root 3 over 2. Shouldn't be too difficult. Okay, we're going to draw our unit circle. Okay, sine of theta equals to minus root 3 over 2. Now, just when I draw the unit circle, I put in my C, A, S, and T. Now it's telling me the sine of theta here is negative. So if it's negative, it's going to be in the third quadrant and the fourth quadrant. So what I'm dealing with will be in the third quadrant and the fourth quadrant. Now, if the sine of theta was equal to root 3 over 2, then theta would be equal to, we go to our log tables, we figure it out, we get 60 degrees. So if sine of theta was root 3 over 2, we'd get theta is equal to 60 degrees. Okay, however, it's not root 3 over 2, it's minus root 3 over 2, which means it's going to be in the third quadrant. So what do? Theta is going to be equal to 180 plus 60. It's also in the fourth quadrant where theta is equal to 360 minus 60. Okay, so you're going to get two answers for theta. 180 plus 60 is 240, it's 240 degrees. Theta is also equal to 300 degrees. So we'll stop there, that's our answer. Question finished, because theta had to be between 0 and 360 degrees. Okay, so that's the first one. Just a recap on yesterday's lesson. No, we had it in class. Okay, now we're moving on to the same question we had for homework last night, which was question 1. I gave you the first 5 parts. This is part 6. I didn't give it to you because a lot of you would have found it difficult. So, part 6 tells you sec theta is equal to minus root 2. Okay, same thing, you want to solve for theta, and theta is greater than or equal to 0 degrees and less than or equal to 360 degrees. It also gives you a hint that says sec theta equals 1 over cos theta. We've never dealt with sec theta. Don't even know what it is really. Okay, it's just the inverse of cos theta. But because we've dealt with cos theta, we'll sub that in here. So we know sec theta is 1 over cos theta. So instead of sec theta, I put in 1 over cos theta is equal to minus root 2. Now, we're only used to dealing with them when cos theta is above the line. So in order to get it above the line, I multiply both sides by cos theta. Multiply this side here by cos theta as well. Okay, so what will happen here? They'll disappear. So you're left with 1 is equal to minus root 2 cos theta. I want to get to cos theta on its own, so I divide by minus root 2, divide this side by minus root 2. What has happened here? They have cancelled. So what I'm actually left with is minus 1 over root 2 is equal to cos theta. Now it's in a form that I can work out. Okay, so originally it wasn't in a form that I could work out. I didn't even know what sec theta was about. It gave me a clue in the question though, which was very handy. Sec theta is 1 over cos theta. They generally won't give you this clue. It will probably be in your log tables and the page that has all the identities. Okay, so I subbed in for sec theta 1 over cos theta, but I don't want cos theta underneath the line, I want it above the line, so multiply both sides by cos theta. I get this line here, which is 1 is equal to minus root 2 cos theta. I divide both sides by minus root 2, so now I'm left with cos theta equals minus 1 over root 2. Now it's just the same as the previous question from here on in. Draw my unit circle, C, A, S, T. Cos is negative. Where is cos negative? Here it's positive, here it's positive. So in the second quadrant and the third quadrant. Okay, so theta. So first of all, what angle gives me, the cos of what angle gives me 1 over root 2. Let me check my log tables. The cos of 45 degrees. So theta would normally be equal to 45 degrees, but it's minus 1 over root 2, so it's going to be in the second quadrant and the third quadrant. So theta will be equal to, so in the second quadrant it's 180 minus 45 degrees, and in the third quadrant it's 180 plus 45 degrees. So theta for this question is equal to 135 degrees, and what's that, 225. That's my answer for theta. Will I keep going with any more answers? No, because they're the only two answers that are between 0 and 360 degrees. Okay, that's not too difficult. I'll do one more example, then I'm going to give you a few questions to do. Okay, so this one here, solve for theta as an element of R, which means what theta is in radians. Theta as an element of R means it could be any number, so we're no longer going between 0 and 360. We're going for any value of theta, and what theta is in radians. Okay, so the cos of theta is equal to minus 1 over root 2. Actually, we just done something very similar to it, but we did it in degrees. Now we're talking about doing it in radians, so it's a small bit different. Same thing with the same idea with the unit circle. Okay, so C, A, S, T. Now, I just got cos theta equals minus 1 over root 2. So cos is negative, so it's going to be in the second quadrant and the third quadrant. Now, we're dealing in radians. So if cos theta was equal to positive 1 over root 2, well then I look at the log tables and I find out theta is equal to, I'm going to take this down in radians now, okay, it's equal to pi over 4 radians. Theta is equal to pi over 4 radians. Okay, so just a small bit more complicated now this one. Pi over 4 radians is also 45 degrees. Okay, so paying attention closely. If it was 45 degrees, okay, but I know it's negative, I would get the equivalent angle in the second quadrant and the third quadrant. So if it was degrees, what would I do? For the second quadrant, I would say it's 180 minus 45. And for the third quadrant, I would say it's 180 plus 45. But we're not doing it in degrees, we're doing it in radians. Still though, it's still easy enough. I get down this far, the only difference now I'm going to make is I'm going to put it in radians. So 180 is actually pi radians. That's pi minus pi over 4 radians, which is what? That's 3 pi over 4. So that's 3 pi over 4 radians. Theta is equal to that. And this side, it's equal to 180, which is pi radians. Remember, a full revolution is 2 pi radians. So 180 is just 1 pi plus pi over 4, which is equal, so theta here is equal to 5 pi over 4. Normally now, I would finish it off. I would say there's my two answers and I'm done. Because when we've been given it by degrees, we've also always been given the question where it said between 0, or your theta between 0 and 360 degrees. But it doesn't say for this case, it just says where theta is an element of R. So I know 3 pi over 4 is somewhere here in the second quadrant. But what could happen? I could come the whole way around. That would give me the same answer again. I could come the whole way around the second time. That would give me the same answer again. I could come the whole way around. So I could keep going by one full revolution to get the same answer. I could keep going by one full revolution. So theta isn't just equal to 3 pi over 4. It could be 3 pi over 4 plus a full revolution, or another revolution, or another revolution. That's a full revolution. It's 2 pi. But I don't know how many revolutions. So to cover for them all, I put in, if we can remember from complex numbers, 2n pi. Now this covers 3 pi over 4, that angle, and any full revolution involving that angle. So I have all them possibilities covered. I have to do the same now on the other side. Theta is equal to 5 pi over 4, which is going to be down here somewhere. But it could be here. It could be a full revolution again, another full revolution, another full revolution, another full revolution. So to cover all the possibilities, I put in 2n pi there as well. So my final answer is theta is equal to 3 pi over 4 plus 2n pi. That's one answer. Or 5 pi over 4 plus 2n pi when n is an element of z. Which means what? If I was to go backwards a revolution, a full revolution, or to go forwards a full revolution, I still get the same answer. So just to recap on that one, it's slightly different. You treat it the same way the whole way down. You're just told it's in radians, and you're told that you basically have to cover every single possible value for theta. This is why this is also, radians are also better than degrees for this kind of a question, because you can cover every single answer in those two lengths. If it was for degrees, you'd have to take ages to cover all the angles. Okay, so cos theta equals minus 1 over root 2, so I know I'm talking about the second quadrant and third quadrant because it's negative. I get the angle for 1 over root 2. I get in radians, which is pi over 4, but I just also get in degrees, which is 45. So if it was in this quadrant, I would say 180 minus 45. That's degrees. I don't want it in degrees, so I put it into radians, which is pi minus pi over 4. If it was in this quadrant, I would say 180 plus 45. Here it's not the same. Okay, it's going to be half a revolution plus that, so it's going to be pi plus pi over 4. That gives me the two angles that I'm dealing with in radians. That only covers this angle and this angle. What happens if I go the full way around again, the full way around again, the full way around again? I could do that for either of them. So just to cover all the possibilities, I put in 2n pi. I put in 2n pi. So it's either this angle, which is 3 pi over 4 plus 2n pi, or 5 pi over 4 plus 2n pi, where n is an element of z, which means it can only be a full revolution, because z has to be a whole number, positive or negative, so it has to be a full revolution, it can't be a half revolution. So that's how you do it with radians. Okay, there's your answer, fully finished. So we've done one question from last night's homework, we've done a slightly newer question, and then this is just the same thing again, but this time you're dealing in radians. Okay, so now I want you just to do the questions that I write down here. If you just bear with me a minute. Okay, I'm just trying to get it up here. So do the following questions, which is page, let me see, page 256, number 1, okay, parts 7 to 9. You're going to use the clues that it gives you, and then when you've that done, okay, I want you to try same page, number 6, try all of it. Okay, question 6, try all of it. Okay, that's it.